It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about how to write our standard equation of the parabola given the vertex and the directrix. So let's have our first one. We've got vertex at 0, 3 and directrix y equal to 5. So one of the ways how to identify or write our standard equation here is through graphing. So I'll show you the graphing first. Later on, I'll show you another way how to go about or go directly to identifying the opening of the parabola, which we wanted or we needed in order for us to write the standard equation. So let's first identify our opening on number 1 through graphing. So let's now plot our 0, 3. 0, 3, we will be plotting since we've got a 0 on x, y with a 3. We'll be plotting that one on the y-axis where 3 is. So we've got 1, 2, and then 3. This is where our 0, 3 is, and that's our vertex. We are now going to identify the directrix, which is y equal to 5. So this is 3 here, moving more up, 4, and then 5. The directrix is said to be at y equal to 5. So this is where our directrix is, passing through the y-axis at y equal to a5. So that is now the directrix and the vertex. So looking at that, we're not going to follow the movement of the directrix because our directrix is always located behind our parabola. So if this is the vertex, most likely our parabola opens this way because again, our directrix will always be behind our parabola. And what is inward? The parabola is always the focus. So we knew from that drawing, our opening is downward. Now let's go to identifying the opening without graphing. By simply looking at the directrix, we've got y equal to a 5. So since the directrix there is y equal to a 5, then there will be only two possibilities that are going to be on the opening of the parabola. That is downward or upward because directrix is with y. Now, comparing that one with the y value on the vertex, our y value here is 3. Comparing that one, our y equal to 5 is located at the top of the y-axis. So, meaning to say, once we are going to identify the opening of the parabola there, the directrix will always be located behind our vertex. So, literally, that is downward. And to look at this, our 3 here on the y on the vertex is less than our 5. So it's right for us to identify that that should be downward as a opening because our vertex is located at the bottom part of our directrix. Now moving on to the vertex, we are to identify the vertex next on this. But the vertex is already given, so we have to copy that one here. I'm always practicing my students to do it like this so that they will know that what we need are the following: the opening, the vertex, the A, or the 4A. So let's now move on to the next one, our A. Now always remember that the distance from the vertex to the directrix is the same as the distance of the vertex to the focus, which is our A. So counting off, we've got from the vertex here, moving to the directrix, we are to count that one. So from the vertex, we have 1 and 2, meaning our A there is a 2. We can also get our A by simply getting our difference of the y values. The y values because our directrix is y, which is equal to 5. So we get the difference between the y value of the vertex and the directrix. So we have here 3 minus 5. This is equal to negative 2. Get the absolute value of that one. Our A is a 2. Next, moving on to 4A. Our 4A is 4 times our a is 2. So we have our 4a as 8. So through there, we can now write our standard form. This is downward, so we start with an x minus h squared equal to, downward, we're facing a negative number there, so that should be a negative 4a times y minus k. Plugging in, we've got x minus our h there is a 0, squared equal to negative, our 4a is an 8, times y minus, our k there is a 3. Simplifying that one, we've got now x squared equal to negative 8 times y minus 3 as the standard form of our parabola. Number 2, we are given with the vertex at negative 2, 5 and directrix at x equal to negative 5. So since we have directrix x equal to negative 5, we will be assuming that our direction of the opening of the parabola will be following the direction of the x-axis. So we've got left or right. So to do that one, we can simply plug that down, the vertex and so with the directrix. We have negative 2, 5, so this will be where negative 2 is. And then we've got 2, 4. So negative 2, 5, that will be somewhere here. This is where the vertex is. And directrix x equal to a negative 5. This will be somewhere around here. So this will be where our directrix is. It's passing through our x equal to a negative 5. So looking at that, this is where our directrix is. That usually is located behind our vertex. So our opening there would somehow be like this. So we know that the opening there is now opening to the right. We can just simply compare the values on our x because the directrix is x equal to negative 5. Comparing that one with our x value, negative 2 and negative 5. Negative 2 is located to the right side of the directrix, which is x equal to negative 5. So it's right for us to say that the opening there is right. So let's now move on to the vertex. We are given with the vertex here at negative 2, 5, where negative 2 is h, our k is a 5. We are now going to have our a, so counting off the number of units from the vertex to the directrix, we have 1, 2, and 3. That is a equal to 3. So another technique there is to simply subtract our different, not the different values here, but the x values, yx values, because we've got the directrix with an x equal to negative 5. So we're looking at the value of your x here on the vertex. So we've got negative 2 minus our x, which is negative 5. Simplifying that one, we have negative 2, negative, and a minus side by side. That would create a plus, and then we have plus 5. A is now equal to a 3. So let's now move to 4a. Our 4a is equal to 4 times our a, which is 3. That's a 12. And of course, we can now write our standard equation. So since this is to the right, which means that we start with y minus k squared equal to the right, we are facing positive numbers. We have 4a times x minus h. Plugging in, we've got y minus, our k there is 5 squared equal to 4a, which is 12, times x minus our h, which is negative 2, and that would lead to a plus 2. And that is what we have for the standard form of the equation of the parabola. We are now on number 3. So number 3, we have vertex at 7, 1 and directrix at y equal to negative 7. So we have y here comparing that one with the y value on the vertex. We have now a picture that our directrix there is located at the bottom part of the vertex. So most likely our opening here is upward. But again, to visualize that one, let me just plot that one. Vertex is at 7, 1. So this is 2, 4, 6, and 8. 7, 1 is here. This is where the vertex is. And directrix, which is y equal to negative 7. Let me just locate that one. Okay, here. This is where our directrix is. It's passing to where y equal to negative 7 is. And you can see that that is very clear. Our vertex there is moving upward. And then we have the vertex with our HK, which is 7, 1. H with a 7 and K with a 1. A here is just the difference, the distance from vertex to the directrix. Vertex is here. We have 1, 2, 3, 4, 5, 6, 7, and then an 8. So our A there is 8. So again, you can just use A equal to get the Y value because we're having a Y on directrix. Our Y value on the vertex is 1, so we can have it as 1 minus negative 7. This would lead to a plus here in between 1 and 7. So that is an 8. And then we move to 4a. Since we have 8 as a, so we can do 4 times 8, which is 32. So simplifying or writing our standard equation, we have opening upward. That means we have x minus h squared equal to upward. We're moving to a positive direction, so we have 4a times y minus k. Plugging in, we have x minus h is 7 squared equal to 4a is 32 times y minus our k is a 1. There you go. We've got that as our standard equation of the parabola. Number 4, we are given with a vertex negative 1, 0 and directrix x equal to 5. So upon looking at this, x is with the directrix. So we're looking at the vertex here as with an x, which is equal to negative 1. So most likely we're moving from, it's either going to be the opening there is right or left following the direction of the x-axis. So anyways, let's try to plot that one and identify our opening. So negative 1, 0, this is where our negative 1, 0 is. And this is where our vertex is. Directrix is at x equal to 5. So we have this line here is the directrix, which is passing through our x equal to a 5. So since we've got directrix here, automatic, we knew that the vertex there is going to be, the opening of the parabola there is opening to the left. Next, we have the vertex. The vertex is already given, which is with negative 1 and 0. Negative 1 for the h, and k is with a 0. Our a, which is simply count from the vertex going to the directrix, we have 1, 2, 3, 4, 5, and 6. We can also verify that one by simply getting the difference between the x values because our directrix is x here. So negative 1 minus 5, our a there is a negative 6. Get the absolute value. Our a there is a 6. So we've got for a, 4 times our a here is a 6. 4 times 6 is 24. We are now ready to write our standard equation. So based on the opening that's left, we are starting off with the y minus k squared equal to the left, we're facing negative numbers. So negative 4a times x minus h. Plugging in. Oops, sorry on that. Plugging in, we've got y minus k, which is 0, squared equal to negative our 4a is 24 times x minus our h there is a negative 1. So that makes it a plus 1. And then simplifying this is y squared equal to negative 24 times x plus 1. So that is how we identify or write our standard form of the equation of the parabola. Moving on to number 5. Number 5, we have vertex at 5, 6 and directrix at y equal to 0. So we know for a fact our directrix is at y. So we are going to base our comparison with the y value of vertex as well. So looking at that, our vertex is located at the top of the directrix. So most likely our opening there is upward. So let's try to see and plot that one. Vertex is at 5, 6. So this is where our vertex is. And then we've got directrix at y equal to 0. This is where our directrix is. This is identical to the x-axis. That is what you got for y equal to 0. So as you can see, our opening there of the parabola is upward. And then we are going to do our vertex. Vertex is with 5, 6. Our h is 5, our k is 6. A is just the distance from the vertex to the directrix. So counting off, we have 1, 2, 3, 4, 5, and 6. You can check it out by simply subtracting our y value. So we got 6 minus 0, that is equal to a 6. Our 4a here is 4 times 6. That will be 24. So writing our standard equation, this is opening upward. So we'll start with our x minus h squared equal to upward. We're facing positive answers on that one, or positive numbers. So we've got 4a times y minus k. Plugging in, we've got x minus our h is 5. And then 4 times a, or 4a is 24 times y minus our k is a 6. So that is how you are going to write our standard equation of the parabola. So this is it. This is your teacher Jenny saying practice and practice and practice, and eventually you'll get this one at the right moment.